today we are going to talk about gas law. So what is the gas? The gas is a substance or matter in a state in which will expand freely and fill the whole container. But gas does not have fixed shape and have no fixed volume. Like here, like the fire, have no fixed shape and no fixed volume. So what is the properties of gas? The gas is based on pressure, volume, amount of moles, and temperature. So the pressure. The pressure is defined as the force that the gas exerts on a specific area or a specific container. And the unit used here, and the unit used for pressure here is Pascal. So 1 Pascal equals 1 Newton over meter square. Meter square is the area, but 1 meter square, or 1 Newton over 1 meter square equals 1 Pascal. So here are some key units at key level: 101.325 kilopascal, 8 m, 760 mm of Hg, which is mercury here, 760 torr, 14.7 psi. So the second thing here is the volume. The volume is a three-dimensional space inside the container holding the gas. The unit here used for the volume is liter or meter cube, but liter here is more common. So here we are going to talk about amount or moles. The amount or moles here is a bit tricky here. Of course, we cannot count molecules due to its small size, but here we can find the number of molecules by using the molecular formula, which is we can convert here the measure of mass in kilograms to a number of moles by using the molecular formula. Here is the molecular formula: concentration times volume equals number of moles. And here, by definition, 1 mole of substance contains approximately 6.022 times 10 to the power of 23 particles of substance. Here is the approximately, and here is concentration times volume. Second thing here is the temperature. Temperature is measured as how hot or cold the substance is, or how fast the particles are moving. So in gas room, of course, some gases at room temperature have low boiling point than other gases. For example, like H2O. H2O becomes in room temperature, it's liquid, but in 100 Celsius, it's gas. Unlike, for example, oxygen. Oxygen in room temperature is oxygen in room temperature is gas. So here we use while working with gases, we use here Kelvin, like more common. Kelvin here is used. So as we can see here, negative 327 Celsius equals 0 Kelvin, 100 Celsius equals 373 Kelvin. So what is the STP? STP is the standard temperature or pressure. As you can see, 0 Celsius or 773 Kelvin, or 18 m, or 101.325 kilopascal. First law here we're gonna talk about is Boyle's law. Boyle's law describes the relationship between pressure and volume of gas. So here we can see that V times V equals Kelvin here, which is K. So pressure times volume equals pressure times volume from the first point equals P2 times V2. So as we can see here, the P1 here, for example, times V1 equals P2 times V2. So here if we multiply the P1 times V1 equals the P2 times V2. So here in this formula it's indirect relationship. Why? Because when the pressure increased, the volume also decreased. Pressure increased, the volume decreased. Okay, so it's inverse relationship. Here it's Boyle's law, named after a scientist named Charles Boyle, which had the relationship between pressure and volume in the mid-1960s. So here how Boyle's law is applied. So when the pressure equals 1, the volume equals 1. So if we multiply each other, the volume equals the answer equals 1. So okay here. So as we said here, the formula equals. So as we said, the P times V equals K. K here is the constant that we don't know. So you can see here, P 1 over 1 equals 1. But 1 times 1 equals 1, and here 2 times 0.5 equals 1. So here we can say when the pressure increased, the volume decreased. When the pressure decreased, the volume increased. So unlike each other. So here how Boyle's law applied in real life, in the syringe, for example. When you build a plunger, the pressure decrease, so the volume increase. Unlike when you push the plunger, the pressure increases, but the volume decreases. So the other law is Charles' law. Charles described the relationship between volume and temperature of gas. So V over T equals K. K is the constant also, but so we can say that V1 over T1, okay, equals V2 over T2. So here, as you can say that any point from V over any point from T, from one point from V over the same point from T, equals V, one point from the second point from V over the same point of T. So I mean here by the same point, like the same line here. So this is the point, for example, and this is the other point. So Charles' law. Charles' law is named after the scientist named Jacques Charles, who studied the relationship between volume and temperature in around the 19th century. He said there is a direct relationship. Okay, when the volume increase, the temperature increase. When the temperature decrease, the volume decrease. So here we can see that when the temperature increased, when the temperature decreased, the volume decreased. When the temperature increased, the volume increased. So here how it's applied in real life. In the hot balloon, when the temperature increased, the volume of the balloon increased. So the other one named Guy Lussac. Guy Lussac said that an absolute temperature, which is K here, of gas directly related and constant mass and volume. So here P over T equals K. K is the constant or the Kelvin as we say here. So P1 over T1 equals P2 over T2 from the second point. So what does it mean? For a gas at constant mass and volume, the pressure and temperature are directly related. When the pressure increases, the temperature increases. When the temperature decreases, the pressure decreases. So there's a direct relationship. So here how it's applied in real life. This is same pressure. So as we said, constant pressure. So here when the temperature increased, the pressure increased. So here, I mean, same pressure, like the same volume. This is the volume, not the pressure. Sorry. I mean, so when the temperature increased, the pressure increased. When the temperature decreased, the pressure decreased. So here you can see that, but it must be in a constant pressure. So here it's applied in real life. Here in the hot pot, the volume of the hot pot doesn't increase, but when we heat it, so the pressure inside that pot increases. So that makes the food cooked fast. So here's the combined law. The law that combines the previous laws into one is P1 times V1 over T1 equals P2 times V2 over T2. So here P1 and V1 here from one point over T1 over T2 from the other point equals P2 from second point over T1 from the first point. So here's how applied. We just do like multiply this here and multiply this here. So the other one is Avogadro's principle. Avogadro say that equal volume of gases contains the equal number of moles at constant temperature and pressure. True for any ideal gas. So here we can see that this is the volume and this is number of moles. So volume over number of moles here equals volume of the second point here over number of moles from the other point here. So what does it mean? So here it means that for a gas at a constant temperature and pressure, the volume is directly proportional to a number of moles of gas. So when the volume increases, the pressure increases. When the pressure decreases, the volume increases. When the pressure increases, the volume decrease. When the volume increases, the pressure decrease. The quantity of moles increased. When the pressure when the quantity of moles increased, the volume increased. When the quantity of moles decreased, the volume decreased. So here you can see that when the number of moles here was less, the volume decreased. Unlike here, when the quantity of moles increased, the volume decreased. So here how is Avogadro's principle applied here. When you blow in the balloon, the number of moles increased, so the volume of the balloon increased also. So here's the ideal gas law. pressure times volume equals number of moles times R constant times temperature. Thank you.